Today I'm going to be talking about how our team uses Unity's cross-platform XR support to make things easier for ourselves most of the time. I'm part of Niantic's Tiger team. That's a small team based here in Wellington that mostly works in the XR prototyping space. We mostly build demos and prototypes for mobile and VR and AR headsets. Originally, our team was part of Magic Leap, then we had our own company called NZXR, then we were acquired by Niantic in 2022. And I've been making mixed reality and AR experiences for around 9 years now. Oops, that's the laser pointer. Okay, first things first, XR is a catch-all term for AR, VR, mixed reality and spatial computing, just getting that out of the way. By cross-platform, I mean XR experiences that incorporate different classes of devices at the same time. Mobile phones, headsets, both VR and AR, laptops and wearables. Why do we do this? Typically we use this to support multiple different roles within an experience. For example, if we're making a headset-first experience, we might use mobile phones to allow spectating, recording and guidance. I'm also including asymmetrical experiences as well, where players on different classes of devices have different game roles and interfaces that contribute together to a single shared experience. Story XR. I'm going to be mentioning Story XR quite a lot in the rest of this talk. It originated in the days of NZXR in 2020. Our team had just separated from Magic Leap and we wanted to continue making multi-user XR experiences, so this is what we came up with. It's a platform built on Unity. Getting good at this. That makes it easier for us to prototype geolocated multi-user cross-platform experiences, GMUCPs for short. Not really. It's implemented as a Unity package. We initially built Story XR upon Unity's existing cross-platform AR foundation, adding Niantic Lightship, Snapdragon Spaces, and OpenXR as we went along. I should mention at this point that Story XR is an internal package and isn't available for external teams, but we learned a lot throughout its development and hopefully you can take some of our learnings and apply them to your own projects. Hey. Just a quick overview of how it works. So to create a Story XR experience, you add the Story XR package to a Unity project, define what we call a story zone, which is a list of positionable objects, yada, 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 set up an experience at a location. You then build a session server executable that incorporates the story zone you just made. Then you go to a real-life location and create deployments of that story zone using the in-engine cross-platform editor. The moment deployments are set up, they are available to devices running the appropriate client app. A little more detail on those servers. A key goal of Story XR was trying to make it trivial to set up these multi-user experiences that could be deployed to these different locations. We also wanted to support persistent experiences with drop-in, drop-out play. So to achieve this, we set up each separate project as responsible for its own session server that handles individual sessions. The compiled session server is uploaded to a shared cloud-based central server which manages deployment data, spinning up and terminating instances of the session server as required. So if I set up a deployment at Frank Kitts Park, a user can find the deployment on a map, walk to it and request to join it, at which stage the central server sees there is an instance of the experience session server running, connects the user to it, otherwise it can spin up a new instance for the player to connect to. This is clients, not anyway. Here's a quick highlight video of some of the first things we built with Story XR. So this is a deployment that we set up in Lyle Bay, multi-user. Here's me using the in-engine editor to position stuff, and then the positional data is uploaded straight to the central server and we can, other people can join. We also tried some sort of education experiences. Again, multi-user. Some sort of physics-based things. And it's weirder when it attacks you in person. And trialing some other sort of applications. There's also the map-based positioning where I can put a giant boat in the middle of the harbor and maybe make a sort of historical experience. Here it comes. And we also more stereotypical game experience maybe, but it was a lot of fun to make that. So I showed some of the example experiences we built. I also want to highlight this phone holder I built, which we call the Technolog. It's a multi-phone holder for when you don't have 3 buddies handy to help you test your 4-person experience. We also made this. This is a great crane cake-off, also known as cakes on a crane.
Let's go, Cupcake!
This is for an XR reference headset that didn't actually have a controller, so you have a crane hanging from your head and a button on a phone that you can use to reel in the crane. This is actually my couch, so it also works for interior.
So it's good as it's going to get, anyway. Let's hope the royal taste survives this ruin of a cake.
So here's something we developed more recently, contraptions. Side note, the logo here you see was designed by legendary designer behind a lot of the early Mac iconography, which I think is pretty cool. The brief was simple: make something cool for the Lenovo A3 glasses and use Niantic Lightship VPS. VPS stands for Visual Positioning System, and it's a way to spatially locate or localize a user as a geographic location using the camera feed. Lightship is also capable of other nifty cross-platform tricks like meshing, depth estimation, and semantic segmentation, which is where the incoming video feed from the HMD can be analyzed and segmented into different channels, like semantic categories like people, floor, foliage, and stuff. So we're trying to make that part of the experience as well. The A3 uses, using Snapdragon Spaces, which is sort of their own Unity package, Qualcomm's, has an interesting feature that if you're using it with a headset, it's tethered to a mobile phone, and you can use that as a secondary display, which they call dual render fusion in Snapdragon. So we wanted to try and use this as well. But ultimately, we ended up with a 2-hand input scheme because it was the least friction when onboarding users. But we also used the secondary screen for a bunch of debugging purposes. Boop, boop, boop. Yeah, getting a quick trailer.
Thinking.
So in contraptions, the idea is that you all work together and see the same contraption, which you'll be seeing shortly. So there are a bunch of contraptions that spit out colored balls, and you're trying to position little bits of pipe and bounce pads and so forth to try and guide the balls into the receptacles that are colored correctly. It's all hand interactions. And all of the gameplay footage was just captured using an iPhone. Yeah, pretty slick video. So ultimately, contraptions was used for a Niantic and Qualcomm demo experience at GDC earlier this year. We ran demos for several hours in a private space with up to 4 people working together. We usually had 1 staff member in the experience at any given time to provide guidance and keep it moving forward. Being cross-platform meant we could observe on a laptop the state of the experience and also use mobile phones to spectate and again ensure everything was running correctly. Contraptions was designed for a specific platform, but we used other platforms continuously during its development. These are other platforms we sort of use regularly, give or take. This is probably my main recommendation today is consider making everything as cross-platform as possible. I touched on the roles we used in contraptions previously, but just to reiterate, we allow as much as possible all roles to run on all platforms. So high quality capture and streaming is super important for XR for a number of reasons. If you can't observe what players are doing, then you have no guarantee that they aren't just staring transfixed at a system menu rather than your experience, which I've seen happen several times. With mobile or headset spectator devices, we can also observe that players are aligned and moving around correctly, particularly if we have attached some virtual content to them. I'm a big fan of putting hats on people, not the only one, and so it's great to actually check the hats are there. where they're supposed to be. Typically, this is enough to verify that they're in the experience correctly. We've used devices as guides or chaperones, often with unique controls, so to drive the experience. And it's also useful if you've got limited hardware, then allowing other people to observe through spectator phones. Here we are, mobile spectators, or streaming a phone to a TV from a mobile fixed camera can allow other people to see what's going on. Should have gone this one. We also think it's very important to capture videos of the experiences so you can share them. So that's why, but a lot of headsets don't really handle it very well, especially AR pass-through headsets use a sort of composite video that comes out. So we often use networked mobile devices, as you saw on the contraptions video, to capture. Extending that, we knew it was very important to be able to set up our experiences. I'm just going to take that off. So that they could be tailored to individual locations. So although you can position stuff in a scan offline, it's much preferable to be able to get on location and position stuff in person. So you can sort of tailor it to as much as possible. So we made it so that all of our tools, the editor, worked on any platform from PC to mobile to headset. We also made it possible for all server roles to be run in the Unity editor or on any platform. So it was mostly just adding UI, the custom UI per platform, but it's something that we've really taken advantage of a lot. If there's connectivity issues or something else, 3G coverage, and if we need to run at 5G, then we might start a session server or a central server on a phone and just have everyone connect to that. So it's been really handy. And a quick shout out to, Parallel Sync is really handy. Obviously Unity 6 has just released some multiplayer tools, so we're going to hopefully check those out pretty soon. Co-location, the word with the most synonyms in XR, localizing, aligning spatially, sharing a space. And I just mean geographically aligning or physically aligning an XR device with a location so that we can persistently position virtual content and also align that user with other users, so everyone is in the same coordinate space. So we need a way of localizing all the users on all the different platforms into a common coordinate space. If everyone's on the same platform, it's usually not too tricky since they can use the same technique, and more on the next slide. But as we add more platforms, it gets trickier to find a common co-location technique. So we use a variety of different kinds of anchors. We've got image trackers. It's 2024 and we're still using image trackers and QR codes. Most platforms support image trackers of some sort. Spatial anchors. Most platforms provide their own spatial anchor system that isn't usually compatible with other platforms. We used to use Azure spatial anchors for a while because they were somewhat cross-platform, but they've been retired. And it doesn't seem like there's any talk of unifying spatial anchors from what I can see in the Unity's roadmap. There's also VPS, so Niantic has a VPS system. It's mostly suited for publicly accessible spaces. It means it doesn't suit all circumstances, but it's, when it works, it's good. And we've also supported various manual anchor types, like pointing at 3 physical locations to generate an anchor. And this is quite point and drag. It's quite common in some VR experiences now. Here's a cool chart. Yeah, they need to look at it. So our initial model required that you had just a key anchor per deployment, and then you could add other anchors. So I could add an image tracker, and then maybe the 3-point alignment on the phone, and then I could get a quest to the 3-point alignment, and then add a spatial anchor, and then from that point on, any quest would be able to localize just using spatial anchors. It is a rigid world model. Some purists will say that's not the best way of organizing your AR experience. It's better to have multiple anchors with content attached to each one, but in my experience, it doesn't need to be too much of a big deal, and it's easy to get multiplayer working this way. We are moving to multiple key anchors, so you can have asymmetrical experiences, which I'm going to talk about now, asymmetrical experiences. What are asymmetrical experiences? Experiences where players can assume functionally different roles in the same game, so that include players on the same platform or on different platforms, where hopefully the differences between the platforms are leveraged to create unique gameplay. One cool aspect of these asymmetrical experiences is that they can be better suited to include players with different accessibility requirements, people who don't want to or can't go into a geographic location. They can play from home or wherever is convenient and from whatever platform suits them. And yeah, it also unlocks remote play for geographically located experiences. Some examples, not ours, at Cron, where a bunch of people on mobile phones compete against a VR player who is a oak tree and they're trying to steal his nuts. Late for work, where one player is a giant ape and everyone else is on their laptops guiding all sorts of military hardware to try and defeat him. Keep talking, nobody explodes. Very iconic asymmetric experience where one person is in VR headset and everyone else is referring to a printed out manual or a manual on their phones or a laptop. And a bunch of others throughout game dev history. The Wii U was sort of introduced some elements of asymmetric gameplay with the tablet. And yeah, so we made a asymmetric prototype, our little team. This is a bunch of scary spiders at the Vogelborn, chilling, and then we need someone to help us. So, who's that in the sky? It's a VR player using hand tracking, and this is their view. So this is the textured mesh that we've got from the Niantic VPS, and they come in with their big hands and start squishing the spiders, saving the day. This can't remember who the actor is, but they really ham it up. Oh, thank you, Dan. Yeah. It's sort of janky, but it gets the point across, I think. And it was quite an engaging experience. We tried it in a few different locations, and yeah, it was pretty fun. Moving on. Some challenges that came out of this were obviously co-location. I think there's a lot of discussion at the moment about what this means, having people in different remote locations working together in the same space. I think that could be another slide, so I won't go into that. Scale was an issue just because not very many systems seem to think that would want to change the scale of an AR experience, but after we'd got through that, the discussion became what the environment looks like. This is a textured mesh, but maybe we could be using like Gaussian splats or a sort of representation of the room layout, or just a top-down map view, or a combination of all of them. It came up as well. A little more detail about rigs and stuff. Each platform has its own rig, so that's just camera, controllers, hands, and whatever AR components we might be using for the experience. So you can see a bunch of different rigs. Helpfully, rigs are often provided by platform providers, so we don't have to do too much work there. And then we network them and simplify them down to a hand, and 2 hands and a body. Normally the hands, that's just the resting position. It's freakish. Side note, a little problem we experience with hands. They're not actually standardized across most of the different platforms, so we have to do some sort of remapping the bone positions before we network them. Otherwise, you get some really scary hands. I couldn't find a good capture, but honestly, they're scary. And I'm going to do one more little overview of one of our projects we did, which was called Remote Assist. The rough goal was to show the benefits of asymmetric experiences for enterprise, maybe non-games, incorporating VPS again. Here's a video featuring some more of my hapless workmates. So in this instance, we're talking about maybe you could put a EV charger outside. So we got a laptop. James has positioned it using the laptop initially, and then he's putting on the VR headset so that he can be experiencing it. There he is. He's the green avatar there with the dapper hat, and he's experiencing the same thing as Joel, but Joel's on the mobile phone, and they work together to try and position that EV charger at just the right spot. You can also send little pings out to sort of give more information. How much? And thumbs up. Great. Just like to finish by highlighting some of the common pain points we encountered. Platform-specific settings. This is the most annoying one. Each different platform needs different script defines, packages, plugin settings, texture formats, especially the Magic Leap 2, OpenXR settings. Also, Android is 4 platforms in one. If you're doing stuff with Qualcomm headsets or Pico or Meta, then you're going to find that they're all bundled in together. So you can't take advantage of Unity's platform switching. And it's expensive to switch usually. So we have this is part of a giant script that I've put together over the years of collecting all of the different settings that need to be modified. And then, yeah, sorry, I haven't come up with a better solution than this just yet. And then we have a tool window that lets us switch between the different platforms that we're supporting, and it keeps track of which one we're on. What about Unity 6 and build profiles? On paper sounds really great, but sad face XR plugins, currently you can't set up and differentiate between XR platforms using build profiles, and I've been pestering them about this, but I'm not sure if it's going to change anytime soon. But at least they're going to add Meta as a completely separate build target to Android, so that at least Meta won't be a problem anymore. OpenXR. I guess it would be nice if we could just use one rig for everything, but we haven't found a way to do that yet. You can't use OpenXR effectively for mobile. Meta support is, I think, lacking for OpenXR. They did say they're committing to OpenXR in 2021, but currently people would most probably recommend you use the Meta SDK rather than OpenXR at the moment, because it's a little behind. OpenXR is a little bit behind in terms of features. Yeah, so we can't make that Uber rig just yet. So we just use it selectively. We do like the XR interaction toolkit, although you end up using a lot of things that come through in sample assets, which get overridden every time you update the samples. Maybe it's a minor little quibble, but it eats up a lot of my time. Or you can rewrite all the stuff yourself, and that's even more time consuming. And I don't like writing PC controls in XR, so I just use the regular Unity UI for that. So to summarize, we try to support all platforms for all roles because we never know when we're going to need them, and we haven't gone all in on XR, OpenXR just yet. Yeah, that's all I got. Any questions? This was the progress bar, if anyone didn't notice. All right, I think that's it then. Thank you.